Hello everyone. I hope my screen is visible to all of you. Hello.
Yeah, it is visible.
Yeah.
Yeah, it is visible.
Okay. So good evening, everyone. As we all know that EVs are booming nowadays, and we are moving toward the innovation, sustainable, and connected to commitments to the greenery futures. And we are working to improve the ecosystem of EV of or e-mobilities. In the last month, EV sales are 91,172, which is record breaking for EV two-wheelers. And the main essential components which we have seen in EV two-wheelers are motor, battery, controller. But to connect all that components, we had a nervous system. That nervous system we called as a wire harness to connect all the components. So in today's session, I'm going to share my view on the topic of wire harness of electric two-wheeler. So in this session, we are going to cover subtopic component specifications like how they are connecting to the controller, motor, battery, which are connected through the BMS. So the connections, whatever the in their component, we are seeing about in the component specification, power flow block diagram, where we can see that how the power is delivering from the primary section as well as the secondary section, where the power voltage should be different. Along with that, we will see about the introduction about AutoCAD. So what was the use of AutoCAD and how we can design a symbol which is not present on the library function of AutoCAD. So we will see that part. After that, we will see also that how you can design any schematic diagram, wiring diagram in the AutoCAD software. So today's motive was to clear about the wire harness as well as we will give towards the software part also. So what exactly wire harness is? Wire harness is an assemble of wires which is used to transmit the power from one point to another point. Basically, a bundle of wires which are required to transmit the power from one place to another place to each of the components we called as a wire harness. Or we can also say that wire harness is a nervous system for a vehicle to connect and coordinate with each of the components to give vehicle ensure smooth and efficient ride. So why wire harness is important? Wire harness is important because it will connect and distribute the powers along with the connecting pins with the having relay itself in the wire harness, and along it will give an efficient output along with you don't have to give a too complex of the wiring connection for the each of the. So we will see that advantages and the disadvantages of the wiring harness. So the advantages we can easily install and which can reduce the assembling time. It will basically use for the assembly lines connections when we are going to design the vehicles or when we do the retrofitting. It's very much easily and give a preferable part like when we are having a lot of wires and it is already defined for a particular components. So it is make very easy to connect that wire for a particular components. Enhance the reliability. Bundles and the protective wires are minimize the risks of electric faults. If we directly connect for a wires for a particular slots and in the initial stage and the joining part was the insulated, so it will improve the quality of the wire as well as the fault detection should be less on it. Space optimization in the less part of space, like we having a lot of wires. Along with a lot of wires, we having different codes like red, black, blue, green, different wire, different OD and ID diameters. But for a auxiliary components, like they are work on the low voltages, so you have to change the components and you have to show the connect the components as per the standard current rating. So these will help you at that time. but the limitations, or you can say as a drawbacks, like a complex to repair. So at the time of repairing the vehicle harness, or for a two-wheeler, for a four-wheeler, it's very complex. But some are the standard methods, like when we are talking about like complex for repairment, when the fault is occurs in any of the wiring connections, so it is very difficult to identify for a particular single wire, like through with that power is not transmitting from that particular part of ore, or we can say like it's required a special skill labor to understand that where is the vehicle telematic issues. But along with that, we are having continuity testers through the multimeters. But somehow in the wire harness is also, it is a single wire is divided into lot of connections. So at that time, it's very create a complex. So these are the little bit small disadvantages which we have seen in the wire harness. But the basic standard wire harness which is used is 8WG gauge of 0.283. Along with that, we are having appliances which are connecting through this. These clips are widely used with the harness while clamping in every area of the vehicles. Clamps are plastic molded part and the mounting of the snappings. Along with that, ring terminals, which is using to connect with the, like from easy to connect a motor controller through the junction box. Along with the close-ended controller, which is connectors which are using for the backlight, tail light of the vehicle telematic vehicle harness, which is high temperature resistance also, like they are having to connect with the battery pack. And along with that, they are having a lot of the terminals connected, relays are also be placed in the wire harness itself, and the fuses are also there. They are using cartridge fuses, like they are having a different power rating, so you don't have to put any different circuit breaker to enhance that. So they simply use a high rating cartridge fuses in the vehicle assembly line, which can improve the wiring harness efficiently. Okay, so as we are told that we will talk about the components of the vehicle two-wheeler. So in the vehicle two-wheeler, as I mentioned, that we having a basics major components like motor, battery.
Hello, Jayesh, you are muted.
Hello. Hello.
Yes, you are audible.
So, sir, I skipped the 2 slides. It may be like whatever the deliver by me was cleared or not. It is audible before few minutes.
Yeah, you are audible. Few minutes.
Okay, sir. So I start with the session from the power diagram connections, like components which are there in the electric two-wheelers. Like basics components in the electric wheelers are PCU, motor, battery. And these are the essential components. Along with that, we are working with the auxiliary components. And the auxiliary component, we use DC to DC converter circuit, as in the, we call also called as a buck converter, which can step down the voltage, and which is that voltage, output voltage that we are getting from the buck boost converter, we will use for the auxiliary components. So in the symbols, you can see that orange color and blue color wires are there. So this is a single line diagram where you can see that a battery is connected with the orange color to the DC to DC converter, controller, and then motor. So basically the high voltage, like a vehicle is having an operating voltage of 48 volt to 72 volt. So at the high voltage, wherever the connection should be there, it is denoting with the orange color. After that, we are connecting with the auxiliary components. So in this, I have chosen for a blue color, but it's a vary. It can be any color like green, orange, light green, black, browns. These are the different colors which are using for the each of components, like for a backlight, headlight, speakers, horn, for in cluster panel also. So we start with the basic specification of the component, like battery. Battery is a primary part where we use, in the EVs, we use battery like a pyramidal cells, cylindrical cells, and we use LFP batteries widely. Along with that, we are designing that battery pack through the fusion welding or a spot welding. So in the spot welding and fusion welding, we are also connect the wires along with the BMS connections. So basically, we are preferring the lithium-ion battery as a preferable choice for EV because of their advantages, like their lightweight. So we can easily make a set of traction battery pack, which is fulfill our desired output. Like we can connect them in a series and parallel combination, and we will get whatever the desired output which we need. It can be fulfilled by that battery pack. So we will use the metallic strips, which is made, the material which is our nickel strips are used for the spot welding or for fusion welding, and we are connecting to the BMS. So in the each of the row and columns, we have categorized like a particular row is connected with one of the BMS wire. In the BMS, they are having lot of wires. In the primary side, or you can say as an input side, you can see that black and blue wire is there. So we are connecting that blue and black wire mid of the battery connection. So the positive connection are going from that battery is directly going to the any controller or motor. But when we are talking about negative connection, so it is denoted like a P minus and D minus. So where the phase connection should be given through the BMS black wire as a negative part, and the blue connection is going to connect with the negative of BMS. So in the our secondary part, where you see that lot of red wires are there. So these wires are connected each of the row of the battery pack. So I will show you one of the video which is from our center only. So in this video, you can see that how the spot welding along with the connections are doing for the batteries. Through the spot welding, we can make that battery traction pack, and these wires are connect each of the columns where we can use for the cell balancing techniques along with the power life. It can improve the lifespan of the lifespan of the battery also, and it will help to improve the fault diagnosis of the battery at the time of fault diagnosis and check the performance, like to identify the which particular row we are not getting a desired output when we are connecting through the any IoT device like a Bluetooth connection or Wi-Fi module. So to allocate or to identify the fault, we need to connect them in the each of the row, and according to the each of row, we can see the performance, that what are the desired output we are getting from that particular row, and we can easily identify them. So these are the connections which are done by our COE staff. So we'll talk about the controllers. In the controllers, we are using controllers are using in the two-wheeler and three-wheeler. A controller is a device, or we can say is a heart part of the EV. Without controller, you can't able to run the motor also. And some of the motors like BLDC motor, permanent magnet synchronous motor, they can't run also without the controllers. Controllers are basically used for basically it is used for the speed approach, speed regulation part, where we having a DTC and FOC control approaches to speed the vehicle, but to connecting the controller with the efficient wire harness along with the different terminals. So it is very complex. Like in the controller, we are having a lot of wires, and according to the features, according to the companies, according to the variations, like it is required for a three-wheeler. So in the three-wheelers, smart controllers are also there. So they are having a fault indications control command on itself also. But when we are talking about two-wheeler, three-wheeler, they are having controller function same, but they are having like similarly, they are having a different voltage range, along with the phase difference of 120 degree. But they are having a similar function, but a different voltage rating capacities. Inside the controller also, they are having a lot of wires along with the connections part, like they're for a phase sequence to delivering the output which is coming from the MOSFETs. Like MOSFET will act as an inverter circuit and in the internal part of the controller, where we are giving a DC power supply, but we are getting a trapezoidal waveform. So it can fulfill the whatever the pole mounting is creating on the motor, like for a positive, for a north pole or for south pole, we are changing the polarities of power supply, which is given by the MOSFET, which is present inside the controller only. So we can call that controller is a driver circuit of the EVs. So we can see that we are having a lot of wires to connect them through the connectors, to the terminals. It is very, you have to very much clear about the wire connections, like which wire is which wire is connected and what are the function of the each of wire. And to identify these wires, EVs are basically maintaining some standard colors. Like for motor connections, they are having standard rate like green, yellow, and blue connections, along with the Hall effect sensors. In the Hall effect sensors also, they're having a 5 wires, along with that self-study conditions, key switch conditions. So speedometer gauge, they're having a lot of connections. But to know about the each of connections, I will show you one of the diagram of controller. So this is a controller which is used for a two-wheeler BLDC motor to command the for hub motor. But you can see that we are having a 3x motor phase wire as a top of the list, where we are giving a power supply to the controller. When we are talking about the controller basics, there are 5 wires. Basic 5 wires, where 2 wires are given for the battery connections as an input to the controller, and 3 wires are for the output from the controller, which is connected to the BLDC motor. Along with that, we are having a lot of wires, which are basis like they are taking a command from it, like they are taking a response from the Hall effect sensor wire. They are giving commands like from the linear Hall effect throttle. A throttle is like an electric throttle, which we are using in the two-wheeler, along with the speed variations, speed variations. These are the lot of wires. But from the starting, we are having a 3 wires, 3x motor phase wire. Second one was the indicator light wire. Indicator light wire, like when we start the vehicle, like it's indicating about green color, neutral position. So that indicator connection wire is also there. Extra neutral wire, which wherever we connect the circuit, we always connect them like a negative should be in the common and the ground connection. So for any the auxiliary required, it can use. Along with that, we are having a throttle wire. To accelerate the speed, we use to connect the throttles. Brake wire, where we use to step the brake up and brakes, along with the power lock wire, brake wire, Hall effect sensor wire, main power supply wire. Main power supply, along with that, they are having also a charging interference. Like they are giving a power supply to the battery also, and to charge down the battery also, they are having a charging interference. So as a part of controller, we are also connect the controller to the BLDC motor through the junction box, or through directly you can also connect if the portal is designed as per that. So in the motor, in the BLDC motor, we have already 8 wires. We have 8 wires, and in the 8 wires, the basic 3 wires, as I mentioned, like green, blue, and yellow wires are the phase wires, 3-phase wires, and along with that, 5 wires are for the Hall effect sensor. So in every and each of the BLDC motor, there are 3 sensors, and these 3 sensors sensing and giving an analog signal, and that analog signals are signal A, signal B, and signal C wire. Along with that, they are to run that sensor, we need a very less amount of power, like 5 volt. So we are delivering a red terminal wire along with the black terminal wire as a positive and negative wire to the each of Hall effect sensors. So we can see all of the basics components. Along with that, we are connecting DC converter. DC converter, as I mentioned, that is a buck converter where we step down the voltage as per the required, we need in the two-wheeler, we are having a 12-volt standard, and auxiliary components like a backlight, headlight, tail light, parking light. So these are the lot of connections along with the horn connections, along with the throttle connections. So these are the basics component you can see in every two-wheeler. So I will show you, I will explain you about the basics connections, because in wiring harness, it's very complex to explain that these wire is for the particularly for this component and for to identify it. And also when we are talking about the wiring harness testing, you can use a multimeter to check the continuity before connecting any of the device, like what are the input pore and what are the output pore. So it can relate that you whatever the desired output after the passing through the component, it's delivered by the power from the battery backup power supply. It's are actually working or not, because sometimes there are components are good, the components lives are good also, but due to the vehicle telematics and due to the wire harness only, it can affect on the components. They are not working efficiently and properly. So in this diagram, I will explain you about the basic primary sections. So here I have divided into two parts, like wherever the high voltage is there, like battery, controller and motor, we call as a primary section, and the outer part where we are running after the DC to DC converter, we call as a secondary part. So we start with the battery function. Battery is going to deliver the power supply to each of the components. So we use as a minimum output voltage to run the electric vehicles. We had a operating voltage of 48 volt to 72 volt. So we start from the 48 volt. After the 48 volt, power is going to the circuit breaker. We use MCB. Basically, MCB is used to provide a protection from overload and short circuit in any of the circuit, and it can save the auxiliary components along with the components like controller and motor. So we use circuit breaker. After the circuit breaker, we are giving a power supply to the positive power supply to the controller. As I mentioned that in the controller, we having 5 basic wires. 2 are the input and 3 are the output. So we are giving the connection like positive terminal and as well as negative terminal. Along with that, we are giving power supply to the key switch. So you can see that we are giving a power supply to the key switch to turn on the vehicle. Just like we in normal conventional vehicles, like we also turn while putting the key, we can turn on the system, like we can turn on the vehicle. Like that only, we have to turn on the controller. To trigger the controller, we use key switch. Okay, so after the key switch, we are giving power supply to the controller. To trigger the controller, then only it can draw on the output voltage, output for the BLDC motor. So these 3 wires are connected through the junction box or directly to the BLDC motor. Along with that, in the BLDC motor, we having a Hall effect sensor. So we are having Hall effect sensors. So the 5 wires are coming also for a Hall effect sensor from the controller only. Along with that, we are having a connections of throttle. These 3 wires for the throttle. From controller only, we are having a brake cut switch. Brake cut switch main function, like in generally we apply a drum brake or disc brake for a braking system. Along with that, in EVs, we are having a brake cut switch, which is mechanically connected to that similar mechanical spring of brake, but it can disconnect the power. We can delivering a power from battery to controller and controller to motor. So it can disconnect the power between controller and motor when we are applying a brake cut switch. Along with that, we are having a reverse forward switch, because basically in any DC motor, while changing the interchange the polarities of motor, we will see that we can change the direction. But somehow BLDC motors are different techniques. So is working on the different techniques. So you can't change the polarity by changing the phase sequence. You can't change the direction of motor. So you can change through the controller only. So you have to give a command only, like for move forward or for reverse back, you have to give a command from the controller itself. So these are the primary sections part. Along with that, I am giving a power supply, red power supply. Red color indicate a positive for the DC to DC converter, and black is connected for the negative. Like we are giving power supply to the DC to DC converter as well as. So in the DC converter, in the input side, we are giving 48 volt, but at the output side, we are getting 12 volt. So these yellow wire and the black wire is the output terminal from the DC to DC converter, and we are giving these connections to the each of connections. Like we are giving a yellow power supply to the headlight. So these power is flow to for the headlight connection and along with the tail light also. So at a time of when you turn on your vehicle, so headlight is also on, and as well as a tail light also. And along with that, we are giving a negative power supply. So you can see that negative is connected to the common to each of them. So yellow color wire, positive terminal is also going to the indicator switch. When we are, firstly, they are going to the blink flasher. After the flasher, they are going for the indicator switch, where when we are giving to indicator, so it can blink for a left direction or right direction. So the power connections, like after the indicator switch, where we having a flasher, like we are giving positive supply for a right connection, and for light blue, it's for a left connection. And you can see that the black color wire is common for both of sides. Okay. So in this connection, these are the components for auxiliary connections. Along with that, we are having lot of connections for horn. For a vehicle telematics, when we are talking about in-cluster panel also, we have to give one of the power supply to the in-cluster panel. Along with the in-cluster panel, they having a microcontroller and converter circuit, which can step down the voltage as per the required to run that in-cluster panel, along with the, like they having an octagon processor. But to run that processor microcontroller, we need only limited, it's a power electronic components. So we need to give a specified low voltage. They are working on the low voltage. So we need to DC converter circuit in that particular panel also. Along with that, to estimation, like we are using in the battery pack itself, we are using one of the BMS. So we can see the SOC of the battery. We can see the DOD of battery, the battery performance. Along with that, they all having one of the separate wire is also going for the in-cluster panel, where we see the vehicle telematics part is there, and they can, whatever the sensors are present on the vehicles, so it can sense that, and it will added with the wire harness itself. So where we make a strong wire harness means we have to make a wire telematic, like in that sense, like all of the component which are required, a basics essential or for a future extensions, we have to look on it, and we have to design the wire harness as per that only. So whatever the components we are using for a vehicle telematics, along with the power primary section, secondary sections, and the auxiliary components, we have to, all of the input and output, we have to understand the connections, then only we are going to design the wire harness of any vehicle, for a two-wheeler, for three-wheeler. Okay. So now I'm going to start with the software part. I hope I'm clearly audible to all of you.
Yeah, audible.
Yes, you are audible.
Yes, sir, audible.
Okay. So these are the basics wire connections for a two-wheeler. Along with that, we are going to talk about AutoCAD and the software. So today's session is divided into two parts for the vehicle harness, telematics, and we will see that how the block designing part was there and the symbol designs in the AutoCAD software. So we will go through the AutoCAD software. So what is AutoCAD? AutoCAD is a 2D, 3D computer-aided design software application developed by Autodesk in 1982, it is very famous and widely used in every of the field, like mechanical, civil, electrical, for a student, for industrial purpose, for automation purpose, wherever you can see that for about motor CAD designing, all of there, the AutoCAD was a too much famous software. So these software is widely used for the industrial engineers, architecture, graphic designers, and the other professionals for a technical drawing. Like we can draw a 2D, 3D models, and we have a overview with the without when we are going for a real life implementation or simulation. Okay. So who use AutoCAD? Like as I told that it's used for the mechanical, electrical, civils, but they are having different software as well as like they are having for a electrical section, mechanical sections, and for the civil section, architecture sections. So architecture in the architecture sections, architectures are used for blueprint and the floor plan for a commercial building. They use AutoCAD. Mechanical section, they design the motor, engine, robot arms, robot, and the innovation part, wherever the mechanical shaft part are there. So they are gear system, they are going to design on the particular mechanical software. Along with that, they are having a electrical engineers. We are using the electrical engineers for a mapping electric system, power station design, like where we are having a substation for a single line diagram, or along with the substation division for using basic connections of the component like MCB, isolator, SF6. So all of the components which are you using, they are present in the software library itself. Along with that, for a civil engineers, they are having AutoCAD for a civil as well as to design the route map of the road and the bridges, and for the commercial background also. So in all of these, but today in our major focus for this session, we are focusing on the electrical AutoCAD. So what is electrical AutoCAD? In this software AutoCAD, we are basically working with the electrical instruments. We are going to design some of the components, having a debugging test. Along with that, we are having a fault diagnosis. Like in real life, we are having a before giving a power supply fault diagnosis systems. Along like that, only in the software we are having a debugging and the error detection system. So if you give a proper specification, proper data to the AutoCAD electric also, so you will get correct responses, correct report from the AutoCAD software. Along with that, you can draw in the electrical sections, as I mentioned that for a single line diagram, schematic diagram with the particular and standard symbols of the electric. So why we learn the electric AutoCAD? As for it's for a student, for a professor, for industrials, it's very useful like for a R&D part, for the innovationary department before while presenting any reports. So it will give a better view to enhance your software knowledge also. You can also go for the better productivity, efficient, professional scope in your career. Along with that, we are having a error checking capabilities. Like before real implementation in life, you can detect the faults in it. Okay, so these are the some of the interference you are seeing while when you are going to sign in the software. We are having a get start when we are in the initial stage, or when you are going for a first time in the AutoCAD software. You can see this type of portfolio where we can see where we are having a lot of drawing sheets. In the drawing sheet, you have to insert or you can import the data, or you can they having a managers itself, like you can combine with the another softwares as well as for to interrupt the data or for to design a particular dimensions as well as. Along with that, before you have to run this software, you have a sign in login ID for this, and these are the license type of AutoCADs where we use for a student or for the education purpose. They are offering a 1-year free license also, so we can use all that AutoCAD whenever you use. In the AutoCAD, we are having a lot of tools along with a lot of features, and these are the some of the basics, and these are the some major head topics which we see in the AutoCAD software of electric: application menu, quick access,
Jayesh, you are muted again.
Hello.
Now you are audible.
So I don't do that, but it's happening simultaneously.
Okay, I am making you a co-host. Just ignore the notification, okay?
Okay. Sir. Okay. So now I am audible.
Yes.
Yeah. Okay. So in the AutoCAD software, we are having a lot of tools and equipments. We are having a predefined standard symbols of electrical symbols like for like MCB motors, three-phase motors. So you can extract that folders and extract that component from the library itself. So we are having a lot of things like tools which are there in the application menu, quick access toolbar, ribbon, tab view, file, drawing sheet, vehicle cube, view cube, along with the navigation bar, layout, and the status bar. So I will explain all of these basics in the software part when I'm going to start the software. Okay. So in this, we are going to design a symbol builder. Like some are the symbols which are already present on the AutoCAD, like motor, battery, but some are the symbols which are not present on that. So I have to design that symbol builder as per your required. And after that, like I explain about the power control systems, power flow diagram of the two-wheeler, where I explain about the battery connections. So you can draw the block diagram as well as their dimensions, specification, and you can, at the time of when we're checking about the report, when we're giving a clear specification about that particular component, so you will get also the report that due in this particular wire or due to this connection, the circuit will not work. So these type of the benefit we are getting from the electrical AutoCAD. After that, this look like this, because in these some are the components are self you have to make that self component from the symbol builder. Along with that, you have to some components which are already predefined in the library file, so you have to directly select like we are having a MCB symbol, battery symbol, BLDC symbols, BLDC motor symbols, along with the name tagging and along with the headlight, flashlights. These are the some basic symbols which are already present on the library function. But for a controller, for brake cut circuit, and for a DC to DC converter, or like to connect for a Hall effect sensor, you have to design a particular component by yourself only. Okay. So I will show in the software part how to design the symbol builder. After that, we are going to again discuss about the power flow diagram in the AutoCAD, and that's it. So I'm going to start my software session. So this was the primary interface where we can see when we are going for a new sheet. So you can use a different templates are there. You can use or you can create your own templates. So from the browser template, I am going to select for electric part. So electric template is using. So this was a primary interface window where we can see with the template. Here is a top bottom A symbol is there. We can call it as an application menu. In the application menu, you can add a new sheet, save a file, import the file, or export the file. Whatever the functions which you are for importing from another software, you can use from here only. Like the above section was about quick access toolbar. In the quick access toolbar, you have to set the functions from each of the connections, like you are using always that particular, and you have to go to identify or to go for some steps and allocate that data, or you have to pick up any tool from many times. So you can add that in the quick access toolbar. Along with that, we are having an info center. In the information center, just like we are using for any PPT, Word, whatever the research, whatever the object, if you are not able to find it, you can easily text it and you can get that particular object. Along with that, we are having a ribbon menu. So in the home only, we are having a lot of components, like to design the shapes, to design the line, schematic diagram, for a single line diagram, different shapes. Along with that, we are having a color coordination, name tagging, blocks, and the clipboards. So these are covered under the ribbons. Along with the ribbon, we having a tab window. We can add different tabs, where we having a start and drawing sheets. We can add different drawing along with the different grid system. And these is a panel, or you can say is a drawing sheet, where we are going to draw any of the component for the circuit part and for the correction parts. Along with that, we are having a view cube. So suppose like in the view cube, you can check the dimensions or from the analyze the circuit from different directions. Okay, so from top view, for north view, for south view, you can do like that, and you can design the circuit as per the requirement. Along with that, we are having a command box. So in the command box, like you can give up your command, like if some of the commands, like when you are doing something and you want to add a new component like square, rectangle, hexagon shape, or you can just simply write a command and it can turn on that system and it can use for that. Basically, AutoCADs are using in the power systems for the electrical part, where we are going to design the substation with having a huge power like 66 kV to 11 kV circuits. We are having a parallel schematic diagrams for their connections, three-phase motor contactor connections. So these are the basics connection where we can see all this thing. Along with that, we are having a layout tab. You can see that we are having a grid tab and the display and the snap tab. Along with that, we are having a ortho projection view. Along with that, in the ortho projection view, best part was that whenever you can draw any of the line, just I say that we are having a line, but you can check that it can rotate for any 30 degree, 45 degree, or for to directly go to 90 degree, it can cover 30, 40, 60 degree. But when we are going for the ortho projection perpendicular view, you can directly always towards the perpendicular direction only. Okay, so you can see that after that you can draw the perpendicular connections only. You can't go for a 90 degree, for 30 degree, 60 degree connections like that. So these functions are very useful when you are going to connect the sheets for in the correct order, or for a floor plan, or for part of electric connection with the contactors, relay, and the fuses. Okay, so we are going to start with the library function. So I start with the new part. So we are also having project. In the project part, you can add, or you can have a zip file adding on it schematic diagram, which is very useful for only the wiring connections from the different wire and different mode of wire, like a single wire, double wire. And along with that, we're having different types of panels. In the panels, we're having a different editors connections, symbol builder connections, icon, where we can store that icon and we can design the new symbols. Reports. In the report part, whatever the debugging or error you can find, it can be generated by the reporting data only. Like you have to give a proper specification and you have to fill all of the columns. Like it is useful for the PLC connections also, when you are going for a ladder structure diagram, or when you are talking about any connector, terminals, connections. So whatever the pictorial part or the schematic part of the connections for the electric connection for a contractor and for the NONC connections, these are very easily shown by the AutoCAD software in it. You can import the data, export the data from Excel sheet or from the another softwares, as well as electromechanical part is a features, external features in the updated version, where we having a conversion tools. We can converse any of the tools along with the required, or you can also self-design the tools for a particular design. Like you are always working on that particular shape. So you can design that particular shape and you can standard that tools in the home page also. Collaborations, expressions tools, along with that features of app. So these are the basic functions where we are getting in the AutoCAD when you are downloading itself. So you have to use all this software. Along with that, now I'm going to start with the vehicle two-wheeler. So I have explained about the vehicle connections, primary component, basics component. So we have basics, essential components. We start with the battery, motor, controller. So I start with the connection, like we having a symbol builders. Along with that, we having an icon menu. Icon menu is act as same as a library of every software. So you can directly import the components from there. Like we are having push button, selector switches, fuse, relay, timer, motor controller, PLC's connections for input output terminals, limited switch, miscellaneous switches. So in each of them, they are having some of the components. Okay. So I will use for a battery. So in the battery, you can go for the power supply. You can just write a text here, and it is used for a scale diametrics. Like it's go for a 1 point. So it is not able to visible clearly. So you have to increase the scale so it can give a clear view in your diagram. Like I will start with the miscellaneous part. So I start with the miscellaneous part. In the miscellaneous, I am going to start with the power diagram. Miscellaneous parts from starting from the battery. So I'm using the battery. Before battery, I want to a scale of 10. So I can set the schematic scale of 10. And just I simply put this. After that, you have to give every evaluation battery, like we are using any LFP battery or battery pack which having a voltage of 48 volt and ampere rating. So you can indicate all that, and you have to describe all of that for when we are going for any specification for any company or for any standard of industries. You have to mention all that data. Okay, so I'm giving simply the name battery, and I'm giving a supply voltage of 48 volt. Okay. And I also need motor. So I choose 3-phase motor. So in the 3-phase motor, you can see that it is not visible clearly because I didn't set the scale. So I have to delete that particular motor, or I have to go for the different motor part. Like I am using 3-phase motor, but its scaling should be, I'm giving a scale of 20. Okay, so I have to give the name. Motor, power rating of 800 watt. So we can see that we are having a icon like this. For a motor connections, we have to add the terminal on it. it can rotate only on the 90 degrees. So I have to turn on the ortho part. And then I'm going to keep this motor in the downside. But now I also need the controller as well as. So I will go for the controller. So we don't find the controller in the AutoCAD. File not founded because we don't have the controller. So we have to design the controller. And here it's come about the symbol builder. So how you can make a particular symbol or particular component for any of the block diagram or for the power regulation part. So I simply take any of the symbols, like I use a rectangle symbol for controller part. I simply giving a name tag on it. I'm clearly audible? Yes. Okay. Okay, so in the connections, I think like the circuit was stuck in some of the place, so I have to disconnect or have to go for the application file and restart that. So I start with the new sheet and I'm about to designing the controller. So I start with the block design part. I'm starting to design one block in the name of controller. Then I have to go for the terminals for a symbol builder in the vehicle schematic symbol builder. So I have to just select the particular object that whatever the object we want to go for to make a component. So I drag this particular part. Okay. After that, I'm getting all the tag files which are there. So you have to copy all this and you have to simply insert the attributes in the sheet. I inserted the attributes. After that, I have to also go for the have to scroll down from the left side, and you have to add the terminals on the controller. Like you have to add, like for a left corner, I want to import like 5 connections. Okay, so I have to insert the wire connection. I think something issue is there, so I will disconnect all the lab files. So okay, time is also there. So we are going to design for the symbol builder. In the symbol builder, we are going to simply go for the AutoCAD software. You have to just import a square shape where you have to go for the part of, in that part, you have to just go for the connections of controller. We have to provide from the symbol builders. You have to give the select that particular object. After the particular object select, you have to go for the icon part, and you have to give the attributes. After the attributes, you have to go for the wiring connections, where you can indicate about each of the terminals. For a left part, like in our controller, we are having a more than 10 numbers of wire, like 12 wire. So we can give in the left side 5 wires and the right side 5 wires. Along with that, in the top and center, we are connecting 2 of the wires for the key switch as well as for the restart the controller. So we have to do all these connections, in particular that part. So after that, we have to go for the insert the wizard. You have to pick up that object and you have to go for the browser part. After the adding the component name, you can make a design like this circuit as I drawn before only. In this type of diagram circuit, you have to go like, as I explained earlier, we are giving a power supply of 48 volt to the controller, and the controller we are connected with the BLDC motor, Hall effect sensor. While the BLDC motors inserted, we are having 3 Hall effect sensors. So these 3 wires, yellow, blue and green wires, are for the Hall effect sensors connections. Along with that, we are having throttle connection from the controller to for the experience with a different approach of DTC FOC connection for a brake cut switch also. If the brake cut switch also, it is connected for the mechanical part to disconnect the power from controller to the motor. And we are having a push-pull connection switch in the yellow color wire also to indicate when we apply a brake, you can see the brightness was increases in the back side of your light. Due to the brake cut switch only, we are having a one push-pull button also in the brake cut switch. Along with that, primary part overs, when we are talking about secondary part, we are having DC to DC converter. So in the DC to DC converter, before that, we are passing to the key switch to trigger the controller also. And we are giving that power to the DC to DC converter to step down the voltage from 48 volt to 12 volt. And we are having a connection of circuit breaker MCBs for a 10 ampere rating for protection of small equipments like auxiliary connections, which are whatever the connections are component connected with this. Along with that, after that, yellow color wire, it indicating about the positive connection. So you can see that it's going for a horn switch. We are connected one of the horn here. Indicator switch for the left and right connections, where orange color indicate about the left connections, right connections, and green color is connected for the left connections. Along with that, we are having a connections for the auxiliary component, like in the purple and the blue wires for giving in the 12 volt power supply to backlight. Along with that, we are connecting a power supply of purple color to the headlight. And you can see the black wire is common to all of them. They are connected to the 12 volt common connections in this particular circuit. This is a circuit of basics primary connection of wire harness of two-wheeler. So these types are they are having more than these wires. In actual real life of the two-wheeler, they are having more numbers of connections. They're having more numbers of connections. In that connections, they're having a vehicle telematics, more sensors wire, along with the SOC estimations wire, along with the features, like we are having a Bluetooth connections, Bluetooth module connections, navigation system, along with the features we are getting for access to the fingerprints access. So we have to design that vehicle harness as per that. So the learning which we are getting from about the wire harness, like what is in the simple, you can say that a wire harness is an assembly of wires which is used to transmit the power from one component to another component and coordinate between of them. So we call that is a wire harness. And this is from my side. Today I'm going to end this session from after completing that software part. So thank you from my side. If you have any query regarding any of the wire harness, you can ask. Hello. Yes, Avinash. If you have any query regarding wire harness, and if you want any kind of schematic diagrams, connections, queries, you can ask any questions regarding two-wheel.
Can we simulate wire harnessing in AutoCAD?
You can't simulate it. If you give a proper estimations about each of the component and specification, so you can check that the wire is connected correctly or not. Like there is no connection of fault, positive and negative connections are mixed together, or they're having any negative connection, or the electric circuit where completing the electric schematic circuit in the power flow from the two directions, or that type of report you are getting from the AutoCAD electric. So you can't go like for a simulation part, like the circuit is exactly to check the wire harness, we can't use the AutoCAD. We can perform the block diagram schematic for the 2D and 3D parts in the AutoCAD of electric.
Okay, so what about SolidWorks, sir?
So in the in the SolidWorks you can work through the for like in the SolidWorks also they are having for different types of connections, like they can perform the evaluation process also. They're having simulation in itself, like when we are going to design any battery, for battery heat resistance and the thermal resistance, it can be evaluated and simulated by the SolidWorks.
Also, this side, Dr. Bharatras Singh. You see, you mentioned that once the braking system just starts, motor gets off. Motor gets off means the running of motor just disconnected.
Yes, sir.
From the power.
Yeah.
And sometimes it is needed if you are your vehicle is just going up or down.
Yes.
So sometimes the braking as well as the motor running is both are required. So in that case, how this can be balanced in the traditional vehicles? Clutch plate is there, everything is there. The people controls. But
I got your point, sir. Like in kind of any inclination slope, or when we are going to apply the brakes, it can disconnect the. So in that case, sir, like it can disconnect the power at instant part, like up to it can deliver by the milli of power seconds are delivered by the power converter itself. For a certain interval of time, it can disconnect the power and it can apply the brakes on it. Like we are using the disc brakes and the drum brakes in the EV. So at the instant, it can stop the vehicle, and if we can while you're running, if you can apply the brake directly from the drum brake and disc brake, it can affect the vehicle balance also, sir. So that's why the power cutoff regulation was there in the controller. When you are applying a brake on the two-wheeler, it can disconnect the power from not a battery. It can disconnect the power from controller to the motor.
Okay.
Yeah, I got your point. And yes, sir.
Then it gets connected when they need.
Yeah. Whenever you can revoke your brake connection switch, it can at that same initial state, it can maintain that particular speed also, sir. If there is speed slowdown is there on that.
Once the motor is that is also under braking condition. Once motor is just disconnected, then definitely it retards the.
Basically, in the BLDC motor, that's why we are choosing also, like, depend upon the performance for a two-wheeler. Like when we are applying a brake, it can having a high initial torque, so it can scope up that particular speed at some milli of limitation of the times also. So
how
whenever
much,
we apply,
how much in milliseconds or some kind of might be.
In the milliseconds it works, like when because they are having a power electronic switches which is under the controller, and we are having the MOSFETs connections. So when we are applying a brake on at a time, it can instantly disconnect the power supply, but after that also we have delivered some of the power to the motor. So for it's a milli of seconds, like it will take 10 to 15 seconds to initially stop the vehicle. Okay. So then whenever it's for upward and slope.
Otherwise, in sloping condition, that vehicle may start going back. So that is what my I was just wondering.
When you disconnect the power supply and we are going for a reverse connection and there is a slope, so it directly can't affect, it directly not go for that part.
Okay, so that controller itself has all these things inbuilt.
Yeah, sir. Like in the algorithm of the controller only, we in the before real life implementation, they analyze all the things, and according to that only, like whenever we are talking about the brakes only, like they are having forward and reverse connection switch in the controller. So if you go for like a forward connection and you suddenly switch the mode to the reverse connection also, that at time also your vehicle is going to stop, and it can stop until you can't accelerate the throttle again. So if you accelerate the throttle again, then it's going for a reverse connection. Firstly, it will stop the motor and then it will go for the reverse direction.
Thank you very much.
Yeah, hope I'm clear, sir.
Yeah.
So if you don't have any queries, any questions, so I'm going to wind up the session from my side. Hope the concerned team will take you.
Yes, it was a wonderful session, and you explained everything very nicely.
Okay.
Thank you.
Happy New Year to all of you.
Wishing you Happy New Year. That is very
Thanks. Thank you, sir.
Everybody who is participating, very happy New Year.
We will meet all of the students in the next year. So hope the concerned team will take the session from at this point.
Okay. Thanks, Jesh, for hosting the webinar. Your expertise and insights were invaluable for our learners. So I just would like to take the opportunity to introduce our company ISIEINDIA products and services that we offer in EV technology with small video. So learners, please have a look.
Hello engineers, do you also want to expand your knowledge of electric vehicles and want to secure a good job in the automotive industry? Let me help you to get there with our online and offline products. ISIEINDIA has been offering specific domain courses as per the industry demands with perks like pay after placement, no cost EMI, placement assurance, global wide certification by Automotive Skill Development Council ASDC and National Skill Development Corporation NSDC Government of India. We have range of courses in electric vehicle, computer-aided design and engineering, including postgraduate certification and executive PG program in EV, professional master certification program, specialization programs, fundamental programs, and internship in EV, CAD, and CAE. Our postgraduate certification program in EV is specially designed for the students with 120 plus online learning hours, 100 plus hours of industrial projects and internship to give exposure of various computational tools for hybrid electric vehicle applications. It is a 12 months assured placement course with pay after placement, thus encouraging the learning without financial constraints. The course is globally valid, certified from NSDC Government of India. Our executive postgraduate program in EV is specially designed for the working professional who want to upskill themselves or looking for a career change in the EV industry. With 120 plus online learning hours, 20 plus hours of industrial projects. It is a 9-month assured placement course with globally valid certification from NSDC and ASDC Government of India. Our professional master certification program in EV, CAD and CAE is specially designed for the undergraduate students to pave their career path by providing industry relevant skills with 100 plus online learning hours, 5 plus hours of industrial projects. It is a 6-month placement assistance course with globally valid certification from NSDC Government of India. Along with the courses for skilling, reskilling and upskilling, at engineering institutes across India, we are setting up a state-of-art facility, Center of Excellence for e-mobility research and skill-based education, which is equipped with research and project-based learning-oriented experimental setups. This Center of Excellence is not only limited to educate the students, but also it will be utilized for research, innovation and product design and development. It is a combination of 6 labs including EV powertrain training and research lab, battery BMS training and research lab, EV charging and battery swapping lab, software modeling and simulation lab, innovation lab and renewable energy lab. Each lab is consist of number of customized workbenches and machineries. Few of them includes EV drivetrain experimental setup and motor testing workbench, hybrid drivetrain experimental setup with data logger, EV machine capacity testing, battery BMS with CAN protocol workbench, V2G setup, on or off-grid work charging station, battery swapping, autonomous vehicle training workbench, solar power generator and software solutions and many more. No matter from which branch you study, we commit to skill and assure you a success in your career. We have spread the joy on thousands of faces, becoming their partner along with the journey towards success. Join us and take advantage to unlock endless career opportunities.
Thanks, learners, for watching the video patiently. So, any of you want to enroll in the courses, kindly send us an inquiry through a QR code displayed on your screen and take your first step towards a more sustainable and exciting future. Thank you, everyone.